Alright, let's get started. Looks like my stream is going. I did a little bit of a change to my setup. I have a new monitor, so I did a monitor switch. So I'm not sure if I'll keep the setup I have. I'm having to turn my head a little bit to see to see the screen I'm streaming on. So let's see if this is gonna work. And I'm looking at my schedule, and I'm not sure it's set up right because it's saying that I'm going to stream again in 24 hours, which that would be Tuesday, and I'm not streaming Tuesday, so it should say one day, 23 hours. I think it's Streamlabs screwing up. Anyway, we'll get started. Yeah, I refreshed my Twitch dashboard, and now it doesn't show the wrong time. Anyway, the plan for today, for me at least, is going to be pretty simple. Last time we started work on a standalone program to host the HTTP server class, and didn't really get completed on that task because found out that we needed to make this HTTP network transport class to kind of integrate HTTP with our network classes. And that pretty much took the whole 4.5 hour stream, plus minus. So moving on to today, I kind of do want to get that program up and running, at least talking to a web client with a 404 response for everything. And I think I'll be able to do that, but we'll see. If I get that done, there are a couple things I wanted to get in there before I do anything else. And one was some diagnostics, and also I want to use JSON for the configuration file for the web server. So I want to get a JSON redirect. And to inaugurate the stream, of course, we have to have the dog bark. And that overlay you saw is whenever I have to mute the mic. So actually might have to mute again in a moment because Doggo is very excited that other people are coming home. Anyway, so a JSON reader and writer is what I'm going to be using to read and write our configuration files. So let's get started on the web server. So web server right now consists of nothing more than just running a loop where we're waiting for the web server to be told to shut down. Last time we made a class that combined the server with a network, so let's add that in here. So in VS Code, I'm going to go to where I have that server. I called it web server, yeah. And CMake list, and I'm going to add in that dependency. It was HTTP network, and I'm already blanking. Oh, transport. Blanking on the name. I'm going to have to adjust this monitor setup because I'm having to turn my head quite a bit to the left. We'll see how this goes. All right, so I want to rebuild to pick up that new dependency. Sorry about that, guys. I actually just had an idea of about what I'm going to do with the monitor situation. I'm going to flip the two monitors, but I'll do that after the stream so I don't have to do any more interruption. Okay, now that we have our network, what is it called again? HTTP network transport. I don't know why that name is slipping from my mind so readily. We're going to pull it in here, and It's sort of got a sort of a clumsy name right now, unfortunately. I think it's because I thought of the name on a day where I wasn't thinking of very good names. Anyway, what we're going to do is we're going to want to mobilize the server with the transport. And we don't have a configuration file yet, so we're just going to hard code the port to 8080. And yeah, this needs to be an auto transport equals. Make sure, because it wants a shared pointer to the transport. And this can return a failure, so we want to exit if that happens. Let's see what that gets us. Alright, so it's web server debug web server. Alright, so I got the Windows Defender warning, so it's binding the network. Let's see what we actually get if we connect to the web server. Localhost 8080. Look at that. We actually got a response. I want to open the what do you call it? Web developer network. Reload the page. Now we can select that and see the headers in the request and in the response. So you can see the response is just the length and the type text plain, because that's what we have in hard coded right now in HTTP server. It's just right now programmed right now to issue that exact reply for any kind of message, unless it's a bad request. So I'm just playing around with reloading. Oops, I didn't mean to do that. Interesting. If I do shift reload, it's, I guess, stuck. So I'm not sure, but I think shift reload is trying to send a request on the same connection. Really need those diagnostics though. If I hit normal reload, okay, sometimes it's coming back with the response, sometimes it's not. There it goes. So it came back with a response that time. Meanwhile, in our web server, we're not getting any visibility there. So, gosh, I didn't think I'd actually get the web server up and running that fast. All we really needed to do was integrate the two classes that we made. The HTTP server network transport and the actual server. And mobilize one with the other. So I guess what we'll do is move on to some diagnostics so we can kind of see what's going on. So hit Control C to shut down there. Let me check that in. Let's see, actually see what kind of changes I did. It should just be in web server, right? Oh yeah, okay. Oh, what happened to my console? That's odd. Control C. That was very strange. Oh, okay. Gotta drag this over to this monitor again. My monitor switch kind of has thrown me off tonight. So all we did was add transport layer. Use HTTP server network transport. and hard code the server port to 8080 for now. So let's add some diagnostics. What we kind of want, we're going to work on the HTTP. Let's go to the HTTP tests, the server tests here. Oh yeah, I had it. I was working on collapsing it with an outline. So I guess what we can do is we can build into some of these existing tests some checks for diagnostics. So what we kind of want to be able to do, oh, this is not for parse actually, it's for the requests. Right, so what we kind of want to do is tell the server that we want to subscribe. And I kind of want to use the same naming convention that I had in diagnostics sender. Subscribe to diagnostics, right? I might actually have to pause streaming to fix my monitor. It's really far to the left. I'm having to stretch my neck over to see it. Kind of ran out of time before the stream started to get this monitor setup going. Okay. Okay, they don't have diagnostics. Blah, blah, blah. We don't have system abstraction that's pulled in for server tests, so let's fix that. Actually, that's HTTP tests. I can tell because the IntelliSense is not helping me. Okay, project file is updated. Now IntelliSense is able to help me again. Alrighty. We're working right up here. I think what we kind of just want to do is collect a list of strings, and we'll build into the string the this actually isn't right, is it? It's this that we want for the message delete. We'll build into the string the sender name and level. So it'll be a vector of strings diagnostic messages. And we'll set minimum level 0. We'll capture that by reference, and we will say diagnostic messages, push back, system abstractions, printf, which we get from string extensions. Let's make it sender, and then in brackets the level, colon, and the message. Sender name, level, message. To make the other one up. C string as well. So I apologize if the audio isn't quite right all the time. I'm having to turn my head to see the monitor. Okay, so let's add these subscribe, unsubscribe to the server, and then what we'll do is we'll just implement it in terms of this diagnostic sender. So I'm just basically going to copy that, and the server is going to be sort of representing that as part of its interface. I'll put it right up here near the constructor. Sort of a long name. Oh, that means HTTP is going to need to pull in system abstractions as well. Okay. Alright, so we're just going to implement them in terms of a sender. Go to where server constructor is. This is server. Diagnostics sender. We just need to make this guy. That didn't really help. Interesting, it didn't know what to look here. This is a helper object used to generate and publish diagnostic messages. I believe this has a constructor that requires an argument. So let's verify that. Yeah, so it needs a name for the source, which means we'll need to have a constructor for our server. I think we already do. Yeah, so we don't have a constructor for the impl though. Let's add that. I always type capital T, capital H by accident. This is the constructor for the structure. So it's gonna require me to do this diagnostic sender. Give it a name. So we'll call it HTTP server. I think that's all we need to do to at least register. But it's sort of not enough to register, is it? Oh, we have to do that. Okay, yeah, I gotta do that after I declare the server. So that registers it. But now let's have it. Let's expect some actual messages back out. So let's expect that when we mobilize it, we'll get a diagnostic message saying that we've bound that port. So what we will do this is we'll assert equal vector of string list construction, and then what did I call it? Diagnostic messages, right? Oh, off by one with hand. So let's expect the string. Actually, there was a space in that, right? No, it wasn't. It was just HTTP server, and then let's expect a level. I don't know. If 0 is debug and 1 is, or 5 was warning, maybe we'll make a 3 like a notice or something like that. It's fighting me on the indentation, but that's okay. Let's say now listening on port 1, 2, 3, 4, right? We'll expect that message. So let's first watch the test fail. Oh, hold on, we weren't done, were we? Let's clear that diagnostic messages, because after we mobilize, we actually send a request. So let's say that that's level 1. Received request from, and then I guess we'll put in 127.0.0.1, I guess. And we have to invent a client port. And we'll probably also want to have one for this connection. I don't know, 4321. We'll put the method there. Received a get, it was what? Get for /hello. And let's also put one here that says, I'm just trying to think, how do I want to format this? I guess we can change it later. Sent 404 not found, response back to. And let's make another one here. I need to remember to clear the diagnostic messages each time. Okay. What I want here is a sort of a message. Let's pick level 2. It says new connection from 4321. So let's watch that fail, first of all. Oh, it's HTTP test debug HTTP test. Right, so we're not getting the diagnostic message. So let's add it. So in the server, when we actually mobilize, we'll change this logic around so that there's a success case. And the success case will generate the diagnostic messages. So send diagnostic message formatted. It just wants a level first. What do we say we wanted? Level 3. And then a format. I'll put it on the same line. And we wanted it to say now listening on port, right? Now listening on port. And then just the number. Port. That's defining int types. There we go. So that should, okay, so it passed the first part. Now we need a message for when there's a new connection. That would be in the delegate that we have set up right here, this new connection. Let's put it here. New connection from, okay, new connection from. Here's where we might need to change our connection interface a little bit, because right now I don't think the connection interface, you can't ask the connection interface for the address or port right now. So let's add something for that. Virtual void. How do we want to, maybe just make it a string? That way we can put whatever we want, and then the actual network, what am I call it? HTTP network transport can construct the string from the address or port number of the connection it received. So yeah, let's make it just a simple string. Then in the unit test for the pretend transport, I can put whatever I want. So let's see, virtual void get ID, I guess, or how about peer ID? Say this method returns a string that uniquely identifies the peer of this connection across the transport, or in the context of the transport. All right, so we have to implement that in two places, right? It's probably fastest just to search in files for that string. Then we can say, we can see that. Let's see. Here's one place. This is the real one. Here's the no, that's not it. Here's the mock one. I guess we can just return mock client, so that, what was it, back up here? I had put stuff up here. I can just say mock client. All right, in the real thing though, we have to do some. Oh, let's make a test for, make sure the real thing does what it's supposed to. That is right here. So we can probably just build it into one of these tests, like we did with that get bound port. Bind, release. Okay, let's build it in here. I think after we call this connect, yeah, it binds as part of connect. So after connecting, we can get the client's port. Oh, wait a minute. I guess not. How are we going to know what port the client's connecting from? Maybe I need to build that into this interface. So right now, this network connection object, you can't ask it what port it's using. You can ask for the other port, but you can't ask for your own port. I'm going to go back and look and see, does the class actually know its own port? It calls bind and then connect. I guess it never really gets its own port number. Maybe because I didn't think that that was important. Well, the server will know. Where was it here? Yeah, but how? Okay, so we need to have some way of finding this out. Maybe we have to bite the bullet and add that too. So that would be in, let's add it to network connection. So network connection has its own test now because we added one. Network connection tests. I had a bunch of tests here, so let me collapse them. Let's do establish connection. Right, so we can get the address of the client through this clients thing. We can just make sure that the client side address matches what the server sees. So it's here. After the server gets the client connection, we can just actually we did it in one direction already. We have the server, the endpoint can get the bound port. We just really need to reverse this. That the client's bound port is equal to the server, what the server sees, which would be clients get peer port. And the same thing, do we need the address? I suppose we do, so same thing. Get bound address. I was just thinking is that you don't know what address you're using until you actually make a connection. If it's a server socket, it's whatever you told to bind, right? But for a client, it's connect. Yeah, so okay, so this is what the server sees. So well, we're just asserting that what the server sees is what we get back when we ask the client what it's using itself, and these don't exist yet. So let's add those. And network connection. Let's add it here. Oh, I had it backwards, didn't I? I was thinking address and I typed port. This method, we'll call this, actually I'm going to call it not bound port, but connected. Local port. No. Bound is probably fine. Yeah. This method returns the IPv4 address that the connection object is using in the current connection. Yeah, that's fine. So you're not it's basically implying you need to be connected first before you can call this, which makes sense. Because it's not until connect that a network connection gets a port or an address assigned to it. This is the IP address that the connection object is using in the current connection. Yep. And basically copy it again for port. Alright, so let's go to is connected here, and we'll just add it. Oh, hi X. Do you use 10 fingers when typing or 2? I use 9 fingers because you don't use your left thumb, right, in touch typing? I never heard of it in the context of Dune. Oh, but yeah, so since I'm calling you Ix, every one of your questions needs to have something to do with Dune, right? Is that like a fun little constraint? 2 fingers, huh? Well, if you're on a mobile device, that makes sense. I made a point in high school to learn touch typing because I felt that I was just not able to type as fast as my brain could go with just 2 fingers. Okay, let's add the function here. So I hope my voice isn't kind of cutting out too much. I'm having to turn my head to see my monitor because I swapped my monitors around. And I don't like this setup. I think after the stream, or maybe if it gets really bad, I might take a break to fix this. But I think I need to move my monitor so that I'm not having to turn my head so much. Okay, that's good. Okay, so getting the bound address and port. I guess we could cache it. I suppose that's what we'll do. So we'll have a cache in our state for that, called the bound address. And the bound port. It'll be similar to this peer address and peer port. This is the, actually I'm just going to copy from the documentation. Connection opportunity is using if there is a connection established. Yeah, I like that. Okay. Oh, I have a little bit of replication there, don't I? Duplication. This is the port number of the connection object using if there's a connection. Okay, yeah. And it's not peer, it's bound. And we actually have to do the real caching, so that's here. I believe what we do is just similar to what's done in the network endpoint. There's like a call to get the address. Let me find that. I think it's get sock address. Get sock name. Okay, there we go. Actually, doesn't the connection have to? No, the connection doesn't do this. The connection just stores it. Actually, I guess it's passed in for the constructor. No, it's in the outer open. Not this, but this. When you call connect, it stores them here. So yeah, it's endpoint that does a little bit of getting the name, right? Yeah, because we're extracting the port number out. So do the same kind of thing. We need this. I guess yeah, we can assume it's an IPv4 address. It's if connect succeeds, then we'll get. Oh, I guess we already have a socket address, so we can kind of hijack that. I guess I can just call this get sock. Where is it? Get sock address. Where did that go? Or get sock name, right? We can just call get sock name. Oh, it wants to actually return the actual size, which we don't really need, but it's part of the API. So in this case, it's bound port and bound address. Syn addr.s, the saddr from the union. And we need to network to host long, that guy. And I did set this up in the test, right? So it should, oh, it's still not happy. Why not? Network connection has no memory bit peer port. Thought it did. Oh, it's a shared pointer. That's why it didn't like it. All right. I guess it didn't finish typing in the next library up from that. Yeah, so this is already inside the impulse, so we can just do that. Yeah, and then here we can say connection get peer ID. Oh yeah, so it was not going to be a port number. It's going to be some kind of string. Yeah, and then we didn't. Here's where we needed the implementation. We're going to return. We need string extensions. And this. Here's where I wanted to return system abstractions sprnf, and this is going to look ugly, but I want to return. I want to print all 8 octets. 1, 2, 3, 4, and then a colon, and then the port number. And my typing's not so good today. Those are, yeah, again defined in int types. So it's going to be what's it? Adaptee get bound address shifted right 24, right? And then just get those lost the bottom 8 bits and convert it to a uint 8. And then we want 16 bits and then 8 and then none at all. And then finally, it's just a get bound port without any casting or masking. Like that. Okay, so first I want to test that the bottom one was system abstractions test, right? Okay, so what test did we modify there? That was network connections test. So it passed here. That test was, no, let's just see that a little bit more directly. Filter equals network connection. Put the star on the wrong side. Let me reverse one of these just so I can see it. Whoops. Finger slip. Try again. Right. So they do match. Let me check that one in first, actually. Zip. Bound port. Oh, I didn't mean to duplicate that line. Network connection. Add ability to get bound address port. These are valid once the connection is established. The bound address port are basically the local end of the connection, as opposed to peer address port. Okay, so that was used in this HTTP network transport stuff. And did I put in a test to check that? I'm not sure now. I'm kind of not remembering what I did. Let's go look. HTTP network. No, so I changed the code, but I didn't actually change the test to match it. I should do that. So yeah, something to verify get peer ID is returning what we expect. Question, do you do any graphical planning before starting to code? Sometimes, if it's something complex. But two things about this web server stuff. I've already done it at work for a project before, and so I know it's at least the stuff I'm doing now is not complex. And the other thing is, I guess that's the only thing. I thought there were two things. Conceptual model of domain that incorporates behavior and data. Yeah, so, oh yeah, there was another thing. The other thing is I'm not very good at drawing UML conceptual models. Maybe that's a bad habit of mine. I just kind of jump into writing interfaces. Visio is pretty good. There were two other ones that I was using. One was a plugin for Confluence. It was called Gliffy, something like that. And the other one was Visual Paradigm, and that was just because my boss at the time really liked Visual Paradigm. But that's sort of a weird Java-based UML kind of drawing tool. Did I get it right, Gliffy? Yeah. I actually really liked Gliffy because I found it really, I could draw UML diagrams pretty quickly with that. Yeah, so I implemented this method, but I don't have a test for it. I think I plan to do one here. I was gonna, after the connection was made, right? Where do we wait for the connection? That's where we wait for data to be received. Here's where we connect and process. Okay, here's where we wait for the connection. Here, so we should probably assert here. So we expect 127.0.0.1, and then I'll have to print it out. PRIU 16. So system instructions. Oh, we don't have that included here either. We're going to ask the client again for its, where is it? How come it doesn't like client dot? Get bound. Well, I guess we should do both. Well, I know it's going to be the loop back address. Really, I don't. Well, the one thing I don't know is the port number. That's what we expect, and then we'll ask the thingy, the transport. Transport. No, it's the. What was it again? Oh, it's the connection. We can ask the connection's peer ID. Oh, right. So that connection is this connections thing. Connections. Get peer. Yeah, there we go. I was drawing a blank for some reason there. I am missing what? I don't think I'm missing anything. What am I missing? Printf. Is it because I don't have int types? Probably. I've grown rather attached to these macros because you don't have to remember it's HU for unsigned 16. You just say printf unsigned 16, and for scanf it's SCN. They actually come in quite handy. All right, let's test that. So that test is an HTTP network transport. Okay, that failed. Its peer ID is all zeros. Okay, that shouldn't have happened. Is it? Oh, because our mock. Is it because our mock? We're using a mock, right? No, we're using the real transport, aren't we? Yeah, this is the real transport we're testing. So the adaptee bound address is not correct. Oh, that's right. That means I need to test. There's two ways you can get a connection, and we only stored or cached the bound address in one of those. So I need to go back to system abstraction tests, and that was in endpoint tests, connection tests. Yeah, so I guess you make it part of endpoint tests because a network endpoint can create a network connection when it accepts a new incoming connection. So probably have a test for that, right? Receive connection receiving. I guess we made connection sending, connection receiving. They're both receiving. It doesn't matter which one, so I'll pick this one. Network, set up the network endpoint, connect. It's when we connect here and we await that connection that we'll do the assert. So that's what we expect from the owner.connections get bound address. And then what do we expect for the port number? I guess we don't know what it is, so we'll have to ask the local side, which is oh, we don't know. We'll have to do the same thing that the connection class does. Get sock name. Or we can do an endpoint. Endpoint has the complete example. No, they're about the same. Okay, I need to set up a socket address, and this is going to be Windows specific, isn't it? Or is it? It actually might be. It might be cross-platform. I'm not sure. That's on my list still, is to fix up this class to work on Linux and Mac. Once I have those set up, here's the address. What does endpoint actually do here? I guess it doesn't have to set up the family. It can it just needs to do that, right? And then this is receiver. And then we can actually just copy this to there and there to there. This needs to be port. Okay. So that test should fail, and that one was back in this one. Right, so there it's failing. So let's fix it. So I believe it's when we call it accept. Okay, so yeah, if we got a new client, we make a connection. Right, so it gets okay, so there's an address and port, but those are the peer address and peer port, right? We need both sets. I believe accept gives you the remote end. It says it's the address of the connecting entity. So yeah, that's the remote address. We also need the local, so we'll call this one remote or peer address. But after the accept call, here's where we want to get another address. And this one's going to be the bound address. And here we have to use this thing, get sock address. What do we do if we can't get our own bound address though? It shouldn't fail. Maybe we'll just set it to 0 since we don't know. So that means I need to kind of get prepared to store it. Bound address IPv4, and then bound address port. And then we can just do this. Well, I don't really need to do that, do I? We can just 0 initialize them in case it doesn't work. They'll end up being 0. This guy there, and this guy there. Oh, I needed the other ones too, didn't I? I didn't really mean to replace them. Shoot. Undo, undo. I just want to have bound address instead of peer address there. Why did I call it address port? I don't know. Let's call it that. Like that. And I guess we'll put the local first. So this make connection from existing socket needs to be updated. Because we have 2 addresses now and 2 ports, not just one. Peer as peer address and peer port. Bound address and bound port. Like that. Let's go where it's declared. It doesn't know where I have to declare it, so I'll have to look for it myself. So it's probably a network connection impl. No? Network connection HPP? Really? IntelliSense is not helping. Search in all files, please. It can't be in just... Okay, that can't be right. Okay, there it is. I wonder why I couldn't find it before. Let's update these. And then add the bound port and bound address. Where did I actually save that? That was in this one, I think. Yeah. This is... Okay, so actually, this documentation is actually wrong. This is the IP address, no, that's not right. This is the IP address of the remote peer. Remote, not report, remote peer. Yeah, okay. Okay. Because I'm calling it peer address now. Okay. So I think we're back to testing system abstractions, right? Just run all the tests. Okay, we failed connection sending. Get bound address is not working. Network endpoint tests. Okay, yeah, so that's back in here. It should have gotten it. I don't know why it didn't work. Is it this platform sock? Yeah, it's not platform sock, is it? It's client. That's probably why. No? Oh, I remember why I was getting that. It's because... Why is that? Why is it off by 1? I think I have them swapped or something. Yo, JD, how's it going? I think it's returning the peer port instead of the bound port. I have them backwards or something. Oh, hold on. It was the header for 132, yeah. Bound and then peer, right? Bound and then peer, bound and then peer, okay. Actually, I'm curious now what all the ports are. So let me go to that test. Okay, it's connection sending, right? So let me set up that test to run in the debugger. Not much, just coding like always. Yay. At the graveyard dev last night. I'm sorry. Last night was Sunday night. What are you doing coding on Sunday night? Let's see. Yeah, so I had that set up to run. Ooh, last time we tested this library, we were testing the clipboard. Network endpoint, right? Specifically, network endpoint test connection sending. Learning, huh? Fair enough. Actually, what I'll do is I'll just tell it to go to there. Now I'm gonna look at this guy. What does it think its ports are? Okay, so maybe they're just swapped. Or maybe I have this, maybe I'm thinking about this wrong. So this socket address is the socket of the receiver. Oh, is that, no? Wait a minute, 12050. Oh, but I have to, let's look at it in binary or hex. Next best thing to binary, 2EEF. And then what was this guy's address? Several clicks down. Okay, so I have the peer port and the bound port flipped somehow. What's the endpoint's bound address? Okay, so it's 2FEF. So do I have those flipped by accident? I think I do. I think I have them flipped by accident. Right, so sender is the server. So we're connecting to that from that. I'm just, for some reason, I'm having a hard time keeping the ends straight. So the bound port should be socket address. Yeah, and they're not. They're flipped. For some reason. Oh, wait a minute. I'm thinking about this wrong, I think. Yeah, okay, I have this completely backwards. It's not, so this bound address is the server side, so um yeah, so it should match the server's address. Sender address. Technically yeah, that means we really don't need to get the address at all from where would we get it from? That's where we called that. From endpoint. Yeah, we didn't really need to do this at all. Because it's just going to be the same as the server's port and address. Oh, we have to do the address part because the server bound can bind to every network interface. This will tell us the exact network interface that it's using to talk to the client. So I suppose we still want to do this, at least to get this part. Yeah. It's just that in the test, yeah, we want to flip it around. Yeah, okay, yeah, that's exactly what we want. So the test was wrong. The code was correct. Code is correct, so let's run the next level up here. Okay, this is off by 1. Maybe for the same reason? Let me check. So that's back in network transport tests. I'm 143. I apologize if I'm slow tonight. You don't know a thing about what I'm talking about, but it's still interesting. I'll try to make it both interesting and something that makes at least a little bit of sense. It's kind of hard here because I'm looking at the guts of the network socket stuff. And it might not make sense unless you've worked with sockets before. If you have any questions about it, though, I'd be glad to try to answer them. Where did my test fail? 143. So on this line. So the bound. So do I have this backwards again, maybe? Yeah, this is backwards. So we don't. It's not the client's bound port. It's the server's. No. That should be right. Peer ID. Oh, probably when I'm constructing the peer ID, I'm using the wrong thing, right? Yeah, I don't want to use the bound address. I want to use the peer address. Get peer port. Actually, that should have been evident by the name. Get peer ID should be the peer address and port. So yeah, terms I'm using, which I might need to add to my notebook. When I'm talking about network connections or network sockets, bound means like your local address and peer means the other guy's address or port. Address is kind of overloaded too because sometimes when I say address, I mean the IP, like IPv4 address. But when you look at a socket, like here, this type socket address has both the port number and the IP address in it. And I'm going to say it's not my fault because I think this comes from BSD. They use the word address here and they use it again here, but these mean different things. This is socket address is the IP address plus the port number. I hate that. I hate when terms are overloaded and you have to know the context. Anyway, everything builds and everything passes now, right? Everything there is passing. So we can go check this stuff in. Let's run all our tests. Okay, HTTP tests are failing. Probably because I was in the middle of something and I didn't finish it. So system abstractions, we'll check, let's see what we changed. Yes, so I added the bound address and port to a new connection object, basically. And also, no, not also. It was just for endpoint. There's the test that confirms it. So network, it's a change to network endpoint, essentially. Store bound address for new connections. All right, and then back in HTTP network transport. Flip. Is it that we added them? Yeah, okay, we implement HTTP server network transport implement get peer ID method. All right, so let's run our HTTP tests to see what's failing. Oh, right. So we're actually getting further. It's failing because we're not actually logging all the messages we wanted to log. Sorry, me. That wasn't the dog. That was me. Someone was telling me the other day I should make different overlays for if I'm muting because the dog is barking or because I'm coughing or something else. Anyway, we need to go back to HTTP. Where is it? Server tests. So the next part we're failing on is 469. So we're getting all the diagnostics now for when a new connection comes in and when we are listening on the port. So we just need to add a diagnostic message every time we receive a request and send a response. That's in server. So here's we're the whole what led us into all that changes to the network stuff is we were adding diagnostics and it was printing out IP addresses and stuff which we didn't have. So we had to add them with this get peer ID. So the next one we're going to add was when we receive a message, right? So that's data received, right? So if it's a valid message, we're going to want to print that we received. And then it's method, right? Request for, and then in single quotes, the URI from, and then the client, right? So it's the method, request method, the string, so C string, and then request target, and then we can ask the target to generate a string from that, and then turn that into a C string. And then the last guy is, I think it's connection state. Connection? Good peer ID, yeah. So that should print a message whenever we receive a request. Now let's make one for when we send a reply. So sent. Well, let's do it. Let's be honest and tell it we sent it after we sent it. Sent. It's the status code and then the reason phrase and then response back to. So it's response. Oh, we don't actually have a response thing formatted. So since the responses are hard coded, I'm thinking we could either cheat and use the client response to parse our canned response, or we can just have, in addition to the response, we can just put it here. Status code, and then reason phrase. We'll have to change all this up when we actually do interpret requests and generate real responses. But we'll just fake it for now. That's one possible response, and here's the other possible one. So, status code, reason phrase C string, and then again the peer ID. You've been working on a login form for React and it's been such a pain, but you're finally making progress. Oh, good job. Login form, huh? So you're probably are you using a grid or are you just using two, what do you call them, two divs? Spans within divs? I'm just kind of curious. I was thinking two because you'd have username and password, and you want like a column for the labels and another column for the entries. All right, so everything builds. Let's run a test. Okay, cool. So now we're getting diagnostic messages, like functionality wise. Okay. Cool. So you had You have some kind of UI, but you're more interested in it actually working. Are you having it log into a real server somewhere? Or are you just mocking the server? Hopefully you're going to say you're mocking the server, right? Because you want to test it in a unit test kind of a thing. Oh, just a simple form. I gotcha. Okay. So now that we have diagnostics in place, we should be able to run our web server and actually see real diagnostics. So there's our server up and running. And here's our client. Let me shorten this so we can see our diagnostic messages. Now when I hit refresh, oh, it doesn't print anything. Oh, because I don't have this diagnostics connected. Duh. We forgot to do that. Let's do that. That's back in our app, right? Yeah, I'm not actually hooking the diagnostic hook right now. So you've been practicing React, so it's not using a server yet? If you're using create React app, doesn't it set up a Node.js server for you to talk to? Or at least have static content? I don't know much about it, so I might be completely off. Okay, so yeah, after we make the server, let's hook its diagnostics. Diagnostics subscription server dot subscribe to diagnostics, and then we need a delegate and we need a minimum level. I wish Visual Studio could be taught my indentation style. That would really help. Okay, we don't need anything in the capture list, but we do need... Oh, you're not using a backend. Okay. Yeah, I understand. So we want to go to diagnostic sender and get our argument list from the delegate typedef. And we will just print them. And I'm gonna do this extra fancy. So what I mean by that is I'm gonna get we already have system abstractions. So from the system abstractions, I have a timekeeper class. System abstractions time. So we can make one of these time objects like this. Timekeeper. And we'll print a timestamp. And then let's do the same format that we did before for unit testing. Sender in brackets level and then the message and then new line. So we'll use the timekeeper. Get time. Timekeeper get time. Is it complaining at me because I didn't end the bracket? Probably. There. Doesn't like me using that. Oh, because I didn't capture it. Well, sure. Let's capture it. There we go. And then the sender name, .cstring, level, message. Okay, now we should see our diagnostics. Basically, the form functionality works like this. If you type your email address and password field in this form, hit enter. It'll determine if you're already registered. If you are, it will log you in. Otherwise, if you don't exist, it'll go ahead and register for you. Okay, cool. Sounds cool. Let me see what's going on. Now we should get, so now we see some diagnostics here. And I guess, okay, so I thought that our timekeeper would auto zero for us, but it's not. So let's auto zero it. That's easy enough. You just do const auto reference time is timekeeper get time, and then we'll just pass in the reference time to the capture, and then we'll subtract that from any time that we have to print. Your friend mentioned that's illegal to do, but you're not releasing it, so it's not really a problem. Why would it be illegal? I guess it depends on what server you're logging into. Because they never gave consent to reg. Oh, really? They have to give consent to register? I didn't know that. I would I would assume that if you try to log in, you're presenting yourself as you expect that there to be an account under your name. Yeah, so the pop-up would probably be all you. Yeah, that sounds good. Because then that confirming is giving consent. I didn't think that you had to give consent. That's weird. I'd be curious to know what the or which law that is. I like to look that stuff up. Okay, so now we see within a millisecond of the timekeeper reference, our server pops up and it says it's listening, but is it really? Other sites do it, so it must be true. Okay, so there I hit refresh and we saw we got a new connection. It didn't print anything. Oh, because why? Actually, I don't know why. Maybe we should be debugging our server and see what it's doing. Stop, refresh, new connection, stop, refresh. I should probably print something when the connection gets broken, shouldn't I? This was working earlier. I was getting that feels bad, man, but now it's not working. Now it's connecting, but it's not receiving the request. Well, I guess we'll have to debug. What if I open a whole new window? Interesting. I actually opened two connections, I think. Eight and 8/10 of a second between them. Network. Hmm. Let's debug it, because I'm kind of curious what's going on. So start up project. I wonder if we have like a deadlock or something. So here's the window. Reload. And now break. Let's see what our threads are doing. So we have our network endpoint processor connection processors. There's two connection processors. Did it open two connections? It did. So there are two connection objects going. They're both waiting for data or something. Um, I suppose we need to look at the web server and see what its state is. Learned about WebAssembly today. Stuff is mind-blowing. Is WebAssembly, is that the... I can't remember the name. That's the tooling that packages all your JavaScript up, right? WebAssembly.org. Oh, this is different. I was thinking of you know, the stuff that packages your JavaScript up into a package. That's what when you said assembly, that's what I thought it meant. Cool. Webpack. Yeah, that's right. You got it. Yeah, so I don't know anything about WebAssembly. I'll have to look that up later. Okay, so what state is our server in? Server. got 2 active connections. I don't need to see it in hex anymore. One active connection has nothing in the reassembly buffer. Second one, nothing also. Oh, these are through interfaces. Yeah, so we can't really see them. Actually, can't I? Click through raw view? Yeah. Wonder. No? I can only see the. Yeah. What's going on with the transport? Hmm. Well, I think what I'm going to do is put a breakpoint when data is received. Go, my friend. Stop. Refresh. Okay, it actually got data. So what happened to the data? Yeah, it's the GET request. Oh, look at that. The data received delegate's not wired up correctly. Why isn't it? That's strange. Did I forget to wire up adaptee? Oh no, we have to set the delegates first and then wire them up. So that would have been in the server. The server, when it receives a new connection, it's supposed to set the delegates and then wire it up. And that is not in data received, but new connection, right? Yeah, it should have done that. Why didn't it do that? Oh, hold on. Maybe it's getting, oh, I think I know what it is. It's a race. So new connection is being called, how do you say this? The data received could be called right away before new connection is even called. That would have been in network endpoint, I guess. No, network, this transport layer. I'm kind of getting lost. So let me search for wire up. I forget where wire up adapter is called. Okay, here it is. Yeah, so a new connection comes in. Yeah, we need to call the new connection delegate and then wire it up. Otherwise, the data could be received before we even this new connection delegate's going to set the data received delegates. Let me see if that fixes it. Although I shouldn't really see if it fixes it, I should make a unit test to describe the bug. But I'm kind of curious to see if that was what it was. There we go. So, new connection. Here's the GET request. Here's the response. Yeah, so shift reload set actually opens a new connection. Reload reuses the same connection. That's cool. I should also print a message, a diagnostic message, when the connections are broken. Because I bet when I'm hitting shift reload in Firefox, it's closing the old connection. Okay, let me make a unit test for the bug I just fixed. The bug is it's calling wire up add t, which in this case is going to start socket processing right away. And it's doing that before we even call the new connection delegate, which in our server's case, the new connection delegate sets the data receive delegate. So if when it's, whoops, that's how it was before. Wire up add t starts a worker thread, right? In the, how do I show that? In process. Process starts a worker thread. I can show that actually. Process starts a worker thread. And oh, I should probably fix that. We don't need this standard move. It starts this processor thread, right? And that processor thread might start reading the socket. And if it gets data right away, basically if that worker thread beats us and gets data right away, it'll say, oh, there's no data receive delegate yet, so the data gets thrown away because the data receive delegate is set by the new connection delegate, which for us is the server here, new connection. So if the worker thread receives the message before the main thread gets to here, we'll lose that first bit of data. So what Firefox is doing is it's making the connection and then immediately sending data faster than our main thread could insert the delegate to receive it. So the fix was to call a new connection delegate first, and then only allow it to set the data receive delegate, and then wire up the adapter to start reading the socket. So the bug is basically in that class, so we should try to capture it in its unit test. There's one here. So let's just make a new test. We'll call it data receive should not race connection delegate. One thing that might make it difficult is we're this class uses the real network, so we might have to be a little bit creative here. This is the data receive delegate, and this is the new connection delegate. We need this one to stall long enough for this one to not get called, or okay. So this code here basically races this send message here, essentially. So we need to make sure that this code is delayed. Let me name my test first. Okay, I already did name my test. Never mind. So bind the network, connect. We start processing. Yeah, because this one is what? Sending. Yeah, this is the client sending to the server. So it doesn't, this is the server sending to the client. So we don't need any code there. That's right. Okay, I get it. So all we really need to do then is put a big fat delay in here, right? Standard thread, this thread, sleep for chrono milliseconds. I don't know, 100 milliseconds ought to do it, right? So now when that new connection comes in, which we can't wait for, we don't want to wait for right away. We want to send this message as fast as possible. We want to send that way up here. So we want the message basically to be caught by the processor and discarded before this line is called. Right, so we don't need to assert that. Yeah. So hopefully this will capture the test. It should be failing now. Capture the bug, I mean. Okay, so that's HTTP transport US test. Yep. Interesting. So I must have a deadlock. Huh. Let's see why it's deadlocking. Shouldn't be. Set to startup. Go. Oh, I had breakpoints. No breakpoints. Go. Okay, so it's in a deadlock of some kind. Let's see where it is. Ready threads, main thread. Okay, it's trying to get that lock. What's holding that lock though? Huh. Why would it just get stuck there? Oh, okay. I had an absurd delay there. That's why. That doesn't need to be 100. I think I only did that for testing because something was taking too long before. I need to reduce that down. We don't want anything to wait 100 seconds in our unit test. That's way too long. That's why. It wasn't deadlocking, it was just waiting a very long time and I wasn't patient enough to see it. Okay, so there's our failure. Right, so basically we didn't receive the data. So hopefully the fix should fix the unit test. The fix is move that to there. So new connection delegate happens first. Oh, it crashed. When you see it run and you don't see a pass or a fail, that means it crashed. Broken connection delegate was called what? Impl was FFFF. Really? Huh. Oh, the test was already returning. Oh, it's actually a slightly different problem. Probably because we changed the timing of things. So, okay, so here it's the network endpoint being closed. Right, so it detected, network connection processor detected a broken connection, but the delegate that we set was already destroyed. Yeah, so we have to be careful about these captures. When this function returns, it destroys everything in reverse order. So it's going to destroy our mutex, our condition, and our connections before it destroys transport. So it's probably a good idea to move the transport down to here. So the transport will be destroyed first before the things that we captured. That's probably what that crash was. Okay, there we go. So now it passes. One of our tests is taking a while to run. Release network's taking a second. Why is it taking a whole second to run? Oh, because connected. Yeah, we knew that from before. It takes us a second to time out and then verify that it can't connect after network's released. Right. Okay, good. All that to fix that one little bug. That sort of bug, that what they call a race condition, can be pretty bad though. Fix race condition. So make sure to call new connection delegate first before firing up or wiring up the connection adapter, because the problem was really that the server's new connection sets the delegate, right? Because the new connection should have called new connection delegate first before wiring it, because the new connection delegate is going to be setting the data received and connection broken delegates. If we were to wire up the connection adapter first, that kicks off a worker thread in network connection, which will start to read the underlying socket. And if data happens to come in right away, it will never reach the data received delegate, because that hasn't been set yet. Okay. All right, let me see what uncommitted changes I have. By the way, this tool Mugget is a tool I wrote in Python. It's in pip, so you can do pip install Mugget, and also it's in public repository in Bitbucket. I like to use it because here, see, I've kind of lost track. I made commits in 3 different repositories that I haven't pushed upstream, and then I have modifications in 2 that aren't even checked in yet. And this is only because I like to do the multi-repo setup. If you're a fan of the mono repo or one repository for everything, then this tool is useless. That being said, if you do have multi-repo setup, Mugget, it's kind of like Android's repo tool. Kind of like that, only a bit simpler. Okay, yeah, this was all about adding diagnostics. So this was the original thing I was going to do after I had the web server running. So add. Oh, actually, I'm not going to check this quite in because I wanted to add a diagnostic message for when a connection is broken. Add diagnostic messages, basic diagnostic messages for connection events. New connections. Connections lost, which I haven't done yet. Requests received. Responses sent. So I'm not going to commit that quite yet. Actually, I'm gonna commit it and then amend it in a second. Need to sleep? Have a good one. Well, see you later, Ix. Have a good sleep. Okay, web server has an unchecked in change. Oh, right. I just wired up the diagnostics. So wire up server diagnostics to standard output stream. I could be a little bit more sophisticated and use a diagnostic stream reporter, but actually, why shouldn't I? That's exactly what I should have been doing. Why am I? This whole delegate I've already written before. So let's do that. So back in web server. It's in system abstractions, right? It's diagnostics stream reporter. I think yeah. So the way that works is you just make one, right? Stream reporter, and you give it the file handles. Oh, it generates the delegate. That's what it does. So standard out, standard error. So that goes in place of the whole delegate here. That's right. And then we don't need the timekeeper. It's supposed to take care of that for us. Let me see how that works. There we go. So I guess I had a slightly different format. It was in brackets, time, sender colon level. That works for me. And let's test it a little bit. So let me refresh. New connection, received a request, sent the response. Cool. Okay, so let me check that in first. Now it's a much simpler change. Ooh, I have an extra line break in there I don't want. It's very handy. Git GUI puts it in a red highlight when there's a line with extra white space in it. Wire up server diagnostic to standard output error streams. There we go. Oh no, not gonna push that yet. Okay, so it was HTTP. I wanted to add another diagnostic message for when connections are broken. So let's see. Do I have a test for when a connection is broken? Let me just fold that together. Do I have one for connection broken? I don't. I need to add one. This will be client connection broken. So transport, server mobilize, make a connection, inform out of the connection. What was this for again? I actually don't know why I had this. Oh, no. Yeah, this data receipt delegate's provided by the server, so we're making sure that the server gave us one. I don't really care because we're not going to actually send the server anything. Right, we're not going to send any requests at all. We're just going to call the broken delegate. And then we're going to assert that we get a diagnostic message out. Where do I have diagnostic messages? Oh, I just had it here. Okay. We'll copy this stuff. And it looked like this, right? Yeah, so let's clear it before, because we should only really care about one message, and make it level 2 because I think the new connection is level 2. So new connection is just new connection from. Let's say connection to mock client is broken. Connection to mock client broken by, or what's the term, like peer closed is, how do I say it? Broken by peer? Because we could break it ourselves. In fact, I want to have that in there as well. I want to do this same kind of thing. I'm actually wondering if we should just make that part of the a fixture so we don't have to keep repeating ourselves. Yeah, let's do that. So let's make a fixture. Fixtures are nice. So what's the test that has a fixture in it? File test maybe? Yeah, here we go. Here's a fixture. So put our fixture there. It's going to be called server tests. And it'll house our server. And our diagnostics thing. So that we don't have to keep repeating ourselves. So that's in the setup here. Tear down. I suppose would be a good idea to unsubscribe on teardown. Which means we'll need to save that. And the diagnostics message we can keep here. And we'll say these are the diagnostic messages that have been received from the unit under test. And then we need to keep this subscription around. What's this type of this guy? This long type here, which is really just an int, I think. This is the subscription token obtained when subscribing to receive diagnostic messages from the unit under test. So here we can say this. And yeah. So test here with the open parentheses can become test underscore F. Now how it gains that server, and we need to go through all of these and remove the local definition of server because it's common now. It's in all of our fixtures. And any diagnostic subscriptions as well. Da 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 da. I forgot I had so many unit tests for the server already. Okay, yeah, that I was wondering if we'd have lifetime issues with that, but it's a shared pointer, so it's doesn't matter so much. Although I guess it would be smart to demobilize the server on shutdown. That makes sure that all of its threads are stopped. Because we don't want anything to still be running when our tests are stopped. Okay, here's a different one though. Here we want to actually destroy the server. So I'll make this a temporary server. Okay, here's one with diagnostic messages, so we remove all of that. Same thing. Okay, just that. Yep. Wow. Do have a lot of tests. Diagnostic messages. Okay, that was the last one. Alright, let's see that that fails. Just on that one test there. Bad function call. Actually, didn't expect a bad function call. Is it because we don't actually set a broken delegate? It could be. This tests. And no filter, hopefully. Yeah, no filter is set, so go. Eh? Oh, okay, so sometimes if C++ exceptions are caught, what you gotta do on the debug menu is, where is it? Windows exception settings, and then you go turn on all C++ exceptions. Then you can see where it's thrown there. Yeah, so indeed, the broken delegate is never set. So that's a bug in our server. And now that I've seen it, I can flip that back to the default there. So let's fix that bug first. Why is this open? I don't know. Server. Probably when we set new connection, we're not setting the broken delegate. We don't need to do anything for now. Actually, we do want to do something for now. We actually want to print the diagnostic message there, don't we? But we'll start with nothing. So I want the test to not crash, but fail. There we go. So it expected to see the broken message, but didn't get anything. So now we'll handle that. So I think all we need to do, actually, we need to do two things. We want to actually print the diagnostic message, and then we want to get this connection object out of the active connections. So hold on, let me double check that this is protected. I want to make sure that's protected by mutex, because these are coming in from different threads. If it's not, then we got to protect those. Oh, it's not. Oh, it is. There we go. So diagnostics sender has its own mutex, so we're fine. But we do, okay, yeah. Do the same thing here where we use the weak pointer. And we do this extra lock here. Although, if that's all that we need, no. We also need to remove it from active connections, right? So let's reword this. Connection to broken by peer, right? And then we do void active connections erase connection state. Okay, let's see if that fixed it. Yay. Okay, great. I do kind of want to see it in action though. And does connection have its own diagnostic? I can't remember. Doesn't. I guess we don't need any. One concern I have is if I have a circular reference problem, I might not see it unless I start instrumenting the destructors to have them print stuff. But another way I would see it also is I think I have this built in. Oh no, I don't. Okay, I need to do this memory leak check. I need to put a memory leak check in here. And let me go off. Let me open a new window off stream because I have this some code I'm not ready to show yet. At least I think I do. Oh no, I don't. Probably have to write it from scratch. All right. I'm not going to worry about it now, but I will make a note. Note. Write code for main program functions that to use the Microsoft CRT functions that detect memory leaks. I want to see that in the web server. When the web server closes, everything should be cleaned up. And if it's not, I'll see it as memory leaks. I'm pretty sure I don't have any circular references right now, but you can never be too sure. I could also have some kind of object counter and then wire up all the objects I really care about, like connections, so that they increment a counter or register themselves with a singleton when they're created and then unregister on destruction. Could do that if I really am nervous about it. Anyway, we should see those connections being closed now when we run the real web server. Let me run all my tests. Okay, all good. So let's run the web server. And flip over to web client, hit refresh. Refresh. Okay, so what happens when I close the tab? Do I have to close the whole Firefox instance? I expect to see that it actually closed the socket. There we go. Oh, and I have a crash. So I think I can actually hit retry and select the debugger, right? No, it's not going to work. Well, let's run it in the debugger and we'll see it. So, web server, start up. Yes, rest in peace, web server. Okay, up and running. I'm actually going to use Chrome because then I don't have to keep closing my Twitch dashboard. Okay, so local host. New connection, sent, received, sent, received, sent. Why did it open 3 connections? I don't know. When we close that, it should start closing the connections. And there's our crash. Let's retry to debug. Okay, there's a resource deadlock in that, getting that mutex. Oh, that's interesting. Oh, okay, so yeah. The connection is calling the broken delegate, and the broken delegate's trying to destroy the connection. So that's a problem. I think I've run into this before. I think I ran into the same problem at work. So we need to establish a rule that delegates responding to an object can't destroy said object, right? So in our servers, where's our broken delegate? Our broken delegate can't do that, because that will destroy the connection, which is calling us to tell it it was broken. So well, what I'm going to do instead is move the connection. I think I foresaw this. I called that our set active connections because I anticipated that we'll need to have a second set for broken connections. And we'll move it to broken connections and then have another thread to that we'll call the Reaper that will clean them up. These are the client connections that have broken and will be destroyed by the Reaper. Reaper thread being a special worker thread we run that its only job is to empty this set. So we'll need a couple things, right? So we'll need the thread, Reaper. We're going to need thread. We're going to need condition variable. And we're going to need mutex. We'll just have it cover the whole server. And then condition variable, Reaper condition, Reaper wake condition. That's good enough. So this is a worker thread whose sole job is to clear the broken connections set. The reason we need to put broken connections there in the first place is because we have a rule to avoid. We have a rule. Well, how do we say this? Because we can't destroy a connection that is in the process of calling us through one of our delegates. One of the delegates we gave it. And this is used to synchronize access to this object. Or to the server, really. Anything that needs to synchronize. Okay, this is used by the Reaper thread to wait on any condition that would that it wants to wake up for. That should cause it to wake up. And we need a flag, stop Reaper. This flag is set. Well, this flag indicates whether or not the Reaper thread should stop. Okay, so we need a method as well. Void Reaper. This method is the body of the Reaper thread. Until it's told to stop, it simply clears the broken connection set whenever it wakes up. It's going to be pretty simple, so it's a standard unique lock of the type of mutex. Lock the mutex, and then we say while not stop Reaper, we say broken connections dot clear. Actually, we need to be careful about this. We don't want to do that while holding the lock, because there could be a deadlock if a connection is waiting to call one of our like data received callbacks. I mean, it shouldn't be the case because it should already be broken. But to be real safe, what we should do is move that set away, right? Move the set away first, because the moment we unlock the mutex, other connections might be added to the broken connections set. Old broken connections, right? Equals standard move, or really we can move construct it from broken connections. And then I kind of like to do this to make it balanced. We need to without holding that mutex, we want to clear the old broken connections so that any connections being destroyed can call us to and can call methods that require us to lock our mutex, from their thread, and completely join their own threads and just get the destructor run to completion. Let all that happen and then relock. Then we will, I guess after doing that, we should clear broken connections so they can be reused. And then we will basically wait, right? So Reaper wait condition dot wait the lock, and then the condition is two things, right? Either Visual Studio, stop biting me on indentation. It's either stop Reaper or not broken connections empty. Okay, and then do we have a constructor, so Reaper. Actually, we don't have to put it in impl because we already have a destructor for our main class, right? Yeah, so we can balance it this way. We can say impl Reaper equals standard thread impl Reaper impl got get, as long as we balance it here by saying impl Reaper join. Oh, we have to do this though. We have to get the lock decal type mutex stop Reaper equal, oops. Stop Reaper is true, and then Reaper wait condition notify all. The reason you get the lock and the reason we get the lock is we're notifying the condition. If we didn't get the lock, there could be a race where I always had trouble remembering this one. You could set the flag, but right before you set the flag, no, that's not quite it. I guess I can't remember. Maybe this lock is unnecessary, but you do need to notify the condition before you set the flag. Oh, I remember what it is. So you could set the Reaper might have checked the flag, it's still false. Then you set it, and then the Reaper thread runs again and checks does the wait thing. But wait will return no. Start over again. So first thing is the Reaper checks stop Reaper flag is still false. Then these two statements run with before the Reaper starts to wait. Notify all only wakes up the thread if it's already waiting. If the Reaper hasn't started waiting yet, that won't wake it up. And so the Reaper will go to sleep even though stop Reaper flag is set to true. So what getting the lock ensures is you can only get the lock when the Reaper is already waiting, because the only time the Reaper, well, there's two cases, right? It's either sleeping or it's clearing its old connections, right? But either way, it won't have started waiting for this flag. So once you get the lock, you set the flag and notify the condition. Then the next time the Reaper gets into that wait here, it'll guaranteed to it has to have gotten the lock first. So when it starts waiting, it's either told to stop already or it'll start to wait for it. Reaper, yeah. I call it the Reaper because it's destroying the old broken connections. So this should prevent the crash we were seeing earlier. Up and running. Let me run my localhost 8080 thing again. And then close it. Oh, still aborted. I didn't fix it. So let's try debugging again, find out why. Oh, hold on. I wasn't finished. I know it's not working. In the broken callback, right? Set broken delegate, it's still erasing it from the active connections. Before it does that, we got to insert it into the broken connections. And we're going to wake up the Reaper there. Reaper wake condition, notify all, which means we'll need to get the mutex. Lock guard. We should have had this anyway because we're touching this. We're touching that from the same thread that we're touching it from here. So both of these, all these need to lock the same thing. So that needs to be done there, and then it also needs to be done here. Does data received also need to? Yeah. I think it does. Probably safe to just lock it in all three places. And there we go. Let's check that in. Actually, can I? Is it going to be too hard to make a check for that? And let me do one of these checks too. It's just HTTP that I have the modifications in. I'm thinking, how hard will it be to make a unit test for that bug? Okay, really we made this fixture so that we could test for a broken client connection. I should have checked that in first, because essentially that was just a diagnostic message. This thing, right? These lines plus these lines, and then finally these lines. And then this, the guard, and then all of that. Actually, no, that was part of the original one too. So we we didn't have a broken delegate before. We should have had one, so we should make a test for that. Let me include that in this check-in. We'll basically do an assert before we call it. So assert true false that connection broken delegate as null pointer. Okay. Two things. So add server add test fixture and expect message on broken connection. Borked, broke, and connection. Okay, so this was the fix for the crash. So how did we detect the crash? I guess we can just have a death test. Yeah, let's put in a death test. So this was the fix, so I'm going to stash that. Stash the fix so that we can put in place a death test. Well, this really is the death test, right? This should actually, should that crash? Yeah, that should crash. Let's see, make sure it crashes. If it doesn't crash, it doesn't crash. So what was it that was causing the web server to crash? It was that the web server was doing something in the, no, it was just, right, the web server was releasing the connection when it was broken. So yeah, so our test is holding on to the connection, right? Where's the connection? It's in the fixture or something? No? Oh, here it is. Yeah, so we want to recreate the environment that, yeah, so let's make another test for this. We need to recreate the environment where the only thing that really holds on, the last strong reference to the connection is the server itself. So we'll make a shared pointer, but then we're going to pass it, but then let's release our strong pointer to it. So we don't need to do that or that. We're not doing diagnostic messages and all that. We are simply going to say, let's make a weak pointer. or a raw pointer really, connection raw. I guess I can do auto here. That's the same thing. When I use auto whenever I can. And then we are going to release our reference to it. And then through the raw pointer, we're going to call a broken delegate. And that should cause a crash because the connection will be destroyed while it's still being called, right? What's this? Oh, I didn't make it its own name. Client connection. Client. The crash was client should not be released during break delegate call. There we go. Unique name. So still doesn't crash. Why does it crash in the web server? I want to run it and see again. I want to get very familiar with what's causing it to crash. Oh, cool. Because of a deadlock. Got it. So I need to set up a deadlock condition. Right, because the real connection, yeah. So it was caused by a reentry of a mutex. So we can recreate that here, right? We can just have mock connection. Oh, hold on. Yeah, we can just have mock connections destructor. We can have it try to get a mutex, and then we can just get it ourselves when we're calling the broken delegate. So let's do that. We need a mutex header though. And then this is used to check to make sure the server does not cause a deadlock by re-entering or causing to re-enter by recursively locking. Really, it's I don't even need it to be a deadlock actually. I can just make a counter or a flag. This indicates whether or not the right, it's when it's being destroyed. So this indicates whether or not the mock connection is currently being destroyed. No, it's in the destructor detects the call. Alright, so it's not as being destroyed. Currently invoking one of the server's delegates. That's what we'll do, and then we'll check it in the destructor. Calling delegate. And set that to false. And we check it in the destructor. So we need a destructor. So it means we need lifecycle management. Lifecycle management. Destructor mock connection. Can I do an assert in a destructor? We'll see. I can't remember. A constructor or destructor may not return a value. I guess not. So we'll make it into a death test. We will force a crash here. So what's my favorite way of forcing a crash? It's to dereference a null pointer. If calling delegate force a crash using a death test. Okay, so connection raw calling delegate equals true. I think we still want to use a mutex because I don't want the return of the broken delegate to be racing, clearing the flag again. So yeah, let's make a mutex for this. Actually, let me think about how to do this. It's during this function call, it's going to call us back to destroy it. I guess this is fine. We just want to make sure it's not destroyed during that point. But when it is destroyed, we want to... No, it's when... It's after the function returns. I think this will work. Oh, but yeah, we should have a mutex, but a recursive one, I think. Calling delegate mutex. This should be held when changing or checking the calling delegate. The reason I'm making it recursive mutex is in the actual case of the bug, this delegate is calling us back within the same thread, so it's going to get the same lock. But the Reaper thread is a different thread, so we do want to allow it to call the destructor, but when it does, I want the destructor to get the mutex first, so that this is guaranteed, this line is guaranteed to run first. Hope that makes sense. Lock guard, call type, connection raw. And then in the destructor, I'll make sure it gets locked first. So it might wait there until that is called, and then we leave, and then it's safe to destroy it, and it will not crash. I think that will work. Okay, so follow my own rules here. Lifecycle management, if I do one, I do all 5. So const equals delete. And then that operator equals. Okay. And yeah, I need to, I usually get that. When you do that, you need to have a default constructor too, explicitly declared. All right, JD. Have a good one. See you later. And there we go. We caught our bug. Thanks. So now I'm hoping that when I pull the fix in, I'm in the wrong directory. Git stash pop. Pull the fix in, that should make our test pass. There we go. All of that test framework there just to catch a deadlock. So fix deadlock issue when connections are broken. Don't destroy connections in the broken delegate, because the broken delegate itself may be called by anything, including the connection that we're going to destroy. Instead, move the connection to another set, broken connections, and use a separate dedicated thread to release the last reference, or really it's to destroy the connection. And all of the signaling that's involved. Yep. Connection variable, mutex thread. Broken connections. There's our thread. There's our flag to stop the thread. Condition and mutex. There's the thread itself, including this special thing to avoid deadlocking. And then we're guarding on all our callbacks. And we are moving it out. Yeah, it doesn't really matter the order in which you do these because we're holding the lock while we're doing it. Yep, that's good. So our web server should actually be in pretty good shape now as far as being robust to new connections and all that. So let's test it out some. I don't know why Chrome does this, but it opens 3 connections. Oh, maybe because one of them is asking for the fave icon. But still, why does it open up 3? It sends 2 requests, but it does it with 3 connections. And I guess that third connection there, actually both of these connections, it's not doing anything with them. It's using 75 for both of the gets, but it's got 76 and 77 open. I refresh. It closes 76, 77, and then opens 3 more up. Why is it doing that? That's odd. You learn something every day. Today I learned that Chrome, when it talks to a web server, likes to open up multiple connections even though it only uses one of them. But you can see our server's pretty robust to those new connections coming in. Okay, Chrome has stopped reopening connections for some reason. Oh, it has to do with the delay in which between reloads. Something like that. Maybe it's just random. Yeah, it just randomly opens up a new connection sometimes. When I hit shift reload, it tries to get that fave icon again. Yeah, when I close Chrome, it closes all of the remaining connections. I wonder if I should have the server print out something like how many connections are still open. Okay, I think we're in pretty good shape. Let me push my changes. And then I'll look at my notebook and see where we stand. Or sit. Oops. Not get GUI, get push. Okay, notebook, where are you? Here you are. Yeah, so I need to do this. I'll research that off stream. I'll do it maybe next stream. I want to write some code to make sure that there are no memory leaks. There's a nifty way to do this with Microsoft's C runtime library. So today we did get our web server up and running. And so I actually thought it would take all stream to do that. So with the extra time, I went and did one of these two things that I had planned to do last stream and didn't get to, adding diagnostics. Did that. So the next thing I think I wanted to do was to work on a JSON reader writer, because I want to replace some of the things that are hard coded in the server with a configuration file. So if we look at the server, where's the web server? Main. We have the port number hard coded. Also, the HTTP class itself has, server itself has some hard coded numbers in here. There's a maximum content length, a maximum header line limit. Those things we should make configurable too. I guess we could make these configurable now as a first step. And then to make the web server program configurable, we'll need the config file, which I want to use JSON for. Let's do these limit things first, though. I'll do that, and then I'll wrap up the stream because for me it's almost midnight. So this will probably take 10 minutes, so that'll be the last thing we do. Let's go to our unit tests for the server. That's where we're going to be changing things. Server tests. So I think what we had a test for one of those lines that were too long, right? Header line too long. And that was assuming it's 999 because the limit's 1,000, including the carriage return line feed. And so this part needs to be no more than 998 because that adds 2 more to put it to 1,000. So that puts it 1 character over. So we should have another one where we configure the line length. Parse invalid header, parse valid header line longer than default. So the difference between those two tests is this will be valid, a valid message. And to make it valid, we will configure the server. Set, what are we calling it? Header line limit. We'll set it to 1001. Actually, rather than having a method for every configuration item, maybe what we'll do is we'll do it with the generic key value thing. There's something like set configuration item. Then that allows it to be extensible. So we'll set whatever I call it, header line limit, and then we'll use the universal type, which is string, and we'll just inside the server class will need to parse that string. That's all we need to worry about. So let's have it return a boolean to detect if it's accepted or not. So server, I guess before mobilize would be a good place. key and value. Oh, we should also have a get too. Yeah. Constant a string key. This method returns the value of the given server configuration item. Just over 80 characters. This is the key identifying the configuration item whose value should be returned. The value of the given value of the desired configuration item is returned. We'll just make it simple where there is no such item. It'll just return empty string, and setting will return I'm trying to decide, should setting an unrecognized item return false or just do nothing? Or a third possibility is it puts it into a dictionary somewhere and just nothing ever reads it. I think I want the third option because then that's forward compatible. You could have a configuration file for a newer server and it'll still work with an older one. Yeah. So in that case, we don't really need a bool. It's just if you set some invalid value, it'll just get ignored, and the default will apply. We'll just make that the rule. Or we'll do something like we'll print out a warning message. This method sets the given server configuration item, sets the value, key and value. This is the key identity configuration whose value should be set. This param in value. This is the value to set for the configuration item. Why do I say desired? I don't need to say desired. No one desires configuration keys. And that was get, now like set. And there we go. So it's going to be really simple. We will probably use a map. So we'll do const auto entry equals impl configuration find key. If entry is the end, matches the end iterator, then we return empty string. Else, return entry second. Right? And then for set, it's really simple. We just say impl configuration key equals value. Now we'll define that guy. Put it at the top. Why not? This holds all configuration items for the server. Standard map. I don't think we have map included. From string to string. Configuration. So we'll want to have some defaults set. But actually, right now we should do proper test-driven development because we haven't really done it properly in a while. And that's where we make sure it builds but fails. Oh yeah, that's right. This does not have a return value. So it builds but does not pass because the default wasn't set. So let's go set the default. Here's a good place. So probably before we start the Reaper, we'll say configuration header line limit. And here's where I will change this from header line limit to default header line limit. To the default maximum length. Is it a ZU? Yep, okay, so that should, oh, what happened here? Oh, because I renamed it. It should pass the first part of the test but fail the second. Right, so it should be a valid request. Now it's not a valid request because it's still using the default. So instead of using the default, wherever that was, here, we'll have it be configurable. So it's header line limit. Right, now we'll have to put this in its place next to the configuration. Because I don't want to parse the string and look it up constantly, we'll have a cache. And I'll change the things a little bit around. Instead of setting it to the default there, we'll set it to whatever it whatever it happens to be. This is the maximum number of characters allowed on any line of a HTTP request, any header line. Actually, we want to have a similar limit to the request line, I think. I don't want to do that this stream because I'm kind of running out of time, but let me make a note to do that. Server enforce maximum line limit on request line. And same thing on the client. Status line. Yeah. So it's set, it's initialized there. Now in set, I think what we want to do is we say if key equals header line limit. And I think what we'll do is we'll just use the scanf, which is in C standard library standard IO. Hold on. We'll do this within an inner scope here. We'll call it new header line limit. I'll say if scanf of the buffer, which is value.cstring, expect a ZU, put it in new header line limit. If that equals 1, and header line limit equals new header line limit. And just because we can, I need to get into the habit of doing this more often. Since we have a diagnostic sender, we can actually set it. Level 0 for debug, and we'll say header line limit changed from ZU to ZU, right? So that's a nice thing to say. It'll be the old to the new. And let's write a test for that here. So right here, we'll clear right before and after, because we'll expect the server to tell us header line limit changed from 1000 to 1001. Oh, interesting. So that means our parse request can no longer be a free function, which makes sense because it needs at least the context of what is the limit. So parse request can no longer be free. Which means probably that we'll need instances in a few places. Yeah, so here. Server. Okay, yeah. Try, so we'll have to relocate try request assembly. Let's just, instead of, okay, it's an anonymous, it's in connection state. But it's, okay, but it doesn't really need to be in connection state. It's gonna need to reach into a connection state to get to the reassembly buffer. Okay, I think I know what I want to do. I want to pass in a server here. Server impl, maybe. Interesting. So the server has a pointer to its implementation. The implementation has a pointer to one of these connection states, and the connection state needs a pointer back to the server. So it's a back pointer. So I think we can just make it raw. So it'll be HTTP server. This is the server trying to reassemble. Oh, this is the server that owns this connection. So we can just do this. It's just now that we have to propagate that, so that means that the impl has to have a server pointer, which is not that big a deal. Let's go to its state here, and we'll make that the first thing. This refers back to the server whose private properties are stored here. I'll make it null pointer in case we forget to initialize it, but that's one of the first things we'll do when we create it. Is we will say server equals this. There we go, that fixed things up. So run our tests. Should get one line further, right? No, it didn't. 634 still failing. 364, right? 364. It's still not valid, really? Interesting. Let's see why. I should have. What if I set it to 10,000? Still fails? That's weird. Oh, hold on. I think I might know why. I don't think it's actually using. Oh, hi, mnlib. How's it going? I'm making my server configurable in terms of its how long a header line it can accept. I think I made this header line limit, but I'm not actually using it. I think that's the problem. Yeah, I'm not actually using it in the key place, which would be wherever that's used, or wherever that's. No, hold on. Where do we actually use it again? Okay, here. That's odd because. Okay, we're gonna have to run this test specifically to see what's going on. Server tests. This one. Set startup project properties. Gtest filter equals. You don't know C++, but you write like zoo to zoo. But I wrote like zoo to zoo. Oh. You mean, or you were saying the %zu? That means that the argument is a size t. So it's safer. It's safer to do %zu than to do %u. Just in case size t isn't the same size as unsigned int. I think that's what you're referring to, right? Okay. Let's see what's going on with this test. The test was 364, this one. I want to see why this request is failing. It's invalid recoverable. Oh, invalid recoverable. Oh, yeah, okay. That's different. Do I have another error? Oh, I do have another error in there. Look at that. I had made that mistake yesterday. I copied from a test that had the colon missing, and I pasted it in a bunch of places, and I never... Yeah, there's another one. I never went back to check to make sure that I fixed that mistake. Let's do that now. So that's the only place where we should see that string is in parse invalid damaged header. Okay, there's a place where it's also wrong. Okay, yeah. I should have done that yesterday. Search for where I might have pasted it in the wrong places. Okay, got further, went to a different test this time. Oh, a bad request became a not found. That's interesting. So 673. Hold on. What is this test doing? Oh, that was damaged intentionally, that one. That was damaged intentionally to check for the bad request response. Yeah, okay, so 335. Interesting. This one should have been recoverable, and instead it told us it's unrecoverable. Oh, yeah, that is unrecoverable, isn't it? We want a line that's too long to be unrecoverable, because that could be a denial of service error. I wanted to be strict on that. Okay, good. So we fixed a few test bugs while we were at it. Wrong repository. So let me check in the actual change first, which is this one right here. Ooh, that was bad. Try that again. I want to stage all that and then unstage this fix here. Okay, so we added a test for changing the header line limit. So that required get and set config item, which required parse request no longer being a free function. All right. Those changes are all included, yes. Yes, all these are included. And these were test bugs, so let's check this in. So this is make a server, make header line limit configurable. And then these were both bugs in the test. Fix bugs in test. It's specifically, it's parse invalid header line too long test. This test is supposed to catch a line that is too long. Instead, it was accidentally catching a broken broken header line. It was catching the fact that user agent didn't have a colon. It's supposed to catch this one where the value is too long. Oh, did I copy that for the next one? Yeah, it's not that it's too long. Its value is long but within custom limit. I like having names that are readable or that indicate precisely what they do and aren't misleading. Back here, this test really does make that line too long, but when we set the limit to be a little bit bigger, it's long but within the custom limit now, right? So clarify or really fix names of variables in test. All right. So I'm nearing the end of this stream because for me it's after midnight, so I'm gonna just do a final check of a few things and then I'll do a recap. And my next stream will be on Wednesday, 9 p.m. Pacific. Right now my schedule, if you look at it, it's about 3 to 4 hours each session. So for me, it's during the week, it's night streams for me, 9 to midnight or 9 to 1. And then some extra streams during the day on Saturday. Okay, so I just need to push some changes here upstream. And I'm going to run all my unit tests to make sure they're all passing. Excellent. And just for the heck of it, for people that have not seen it already, let's run the web server. So what we did today was we made webserver.exe host our server using the actual network, and we have some diagnostics so that when we do stuff like go to our server, it tells us when the connection's opened, that it receives the request, and what it sent as a response. Right now our server is very dumb. It will only send a 404 not found if the request is valid, or a 400 bad request if it's not valid. And you can see that the text in our 404 is feels bad, man, because this is a Twitch stream and I have to use Twitch memes. So yeah, every time I hit refresh, it's going to make a new request. And if I hit shift request, what I've discovered today what Chrome does is it actually goes and tries to get the document and also tries to get favicon.ico. And it does some other curious things too. I've seen it open multiple connections to the server. Not doing that now. It was doing it earlier though. But anyway, it's keeping the connection open, you can see. And when we close Chrome, you can see the connection finally closes on the server. And there's a new one. And you can actually see that time it opened 2 connections. It's only using the first one. I don't know why it opens the second connection. It never really uses it. In fact, there when I hit refresh, it closed that second connection and just went back to using the first connection. I wonder if that has to do with Chrome expecting to be loading multiple documents in parallel, and it's sort of getting the connection set up in advance so that it could load faster. I know that Firefox is not doing that. If I go to Firefox and open a window to our local host, it only makes 1 connection, and I never see it open a second one. Oh, okay, not true. If I hit shift reload, it closes the connection, opens a new one. Oh, actually it did open a second one there, but it closed it 5 seconds later. I guess it figured it didn't need it. Well, thanks, mnlib. So I guess next stream I want to add a configuration file for stuff like this header line limit, because right now we could set it up here before we mobilize the server, but again, it would just be a hard-coded number. I want to have things like that header line limit and the port number configurable. So we'll do that by making a JSON library. And where'd my notebook? I closed my notebook. Why did I do that? We'll be making a JSON reader writer to handle the configuration. So make good progress today. Yesterday we had started making the program and intended to make diagnostics in JSON reader writer. Today we actually got that program running, added the diagnostics, and did a bunch of bug fixes. So I have some notes I took. We need to be checking for memory leaks. I'll research how to do this. I've done it before, I just don't remember. And some notes on things that we need to add later that I don't have time to do tonight. And there were some other things that we need to fix in the web server. One thing I noticed, I'll show you guys if I can find out where that was again. RFC. If you look at the RFC for HTTP, there's the host header, right? It says the client must send a host header. So we're not checking for that in our server right now. So probably next stream, or very soon, I'll have to add code to check that. And that might go along with supporting other protocols, because it talks not exactly here, but in nearby sections about differences between HTTP 1.0 and 1.1. So let's see. Yeah. I think next time, which will be in 2 days, we'll be doing a JSON reader writer, and fixing up some of these things that I made notes about. And that'll probably take the whole stream, because I'll spend a lot of the time on making the JSON reader writer, which would be kind of a fun side project. So yeah, I think I'm going to wrap it up here. And thank everybody for watching, and hope to see you again in a couple days. Have a good night, and I'll see you soon.